everyone. So today is, let's find, okay, schedule here. Today is Monday. It's also the due dates of all your homework up to 3.4. And today you have quiz 3. Okay? So I would say like by the midnight, please submit all your homework. Okay, so if you're doing your homework problems now, you can submit it and then you can see the solution. Remember, I told you you can print out the solution as a PDF, and you can know what's the correct way to solve each type of problem. And then if you have some mistake, you don't get like full 10 points. It's okay. You can open the second attempt and work on the problems that you got wrong in the first attempt. Okay, everybody? So yes, read the solutions and understand like how to solve each type of problem. And some of you like email me, and I realize sometimes the Mobius like asks the wrong problem. I think the student emailed me the question is about we have 2 lines, and each line was giving 2 points. So you have to figure out the slope, and you tell whether those 2 lines are parallel or perpendicular. And then the first line, the 2 points were given, actually were the same points. So Mobius made mistake. He gave like 2 identical points for that line. In this case, the problem is wrong. Okay, you cannot find the line where you're only giving 1 point. 2 points can fix the line, but only 1 point, the slope is not defined. So you can submit the attempts, and then Mobius might say you're wrong on this problem. But when you open the second attempt, it will generate a new problem, maybe with different new points, and then you can work on that problem. Okay, everybody? So you have unlimited attempts for your homework. Okay, so we'll do midnight, and I see some of you already completed, and but for more than half of you still have some homework missing. Okay, so don't forget to submit your homework. If for those of you who didn't finish your homework by midnight, I will email you and ask you to come to my office to meet with me. Okay, and we also have a quiz today. So the quiz is about sessions 3.1 to 3.4. Okay, are you able to see the quiz in Blackboard? Yes. Okay, so it's unique. Any questions so far? Okay, when is our exam? Friday. Right. So exam is this Friday. It covers chapter 1 to 3.4. And bless you. The practice exam is on our website. Okay, so this is a practice exams. And your actual exams will have less problems than the practice exam. Okay, and remember Friday we're gonna meet at what? 12:20, and then you work until 1:50. So you have 1.5 hours to do the exam. So for those of you cannot take it on Friday, let me know. Okay, let me know earlier so we can schedule a time to take the exam. So far so good, everybody. Okay, let's look through the practice exam. So this problem we were like giving the graph, and we want to find the domain, right? The domain is kind of you project the graph on the x-axis and you read out the x values, right? And the range we kind of project on the y-axis and you read out the y values. And then g of -2, you plug in your x value to find the y value, right? Similarly here, if for some points, like this point, do you see that both open circles? That means that the endpoint is missing. So at that point, is so g of 1 is not defined. Can you see that, everybody? And here, a solid point means that the endpoint is there. Okay. Empty circle, open circle means the point is missing. And questions? Oh, no? Okay. And then this one, find the x value such that the y equals -2. So you're looking at the y is -2 to find the x values. Okay, everybody? So two different directions. Given the x values, find the y value, or given the y value, find the x values. So we can look at the graph. And then determine the interval on which the function is increasing, right, going up, or decreasing, going down. And relative maximum and minimum. Remember, relative maximum values is about the y value, okay? But then you can also tell me f has relative maximum value is which number, x, what's the x value, okay? Everybody? All right. And then this problem, transformation, section 1.5, right? And I would say, what are the functions that we learned? Okay, your left move. Again, show your hands. Line. X squared. X cubed. Square roots. Cube roots. Absolute value. Right? And remember those key points. So plot the key points. Label the important points. And then the transformations. What's the first one? Shift left or right. Left is positive, right is negative. And then second step, refresh over the y-axis. Okay, then you will see a minus sign in front of the x, right? And maybe horizontal compress. And then the third one, refresh over the x-axis. You will see a minus sign in front of the whole function, right? And vertical stretch. The last one. Up or down. Yes. Okay, good. And this one, okay, line perpendicular and parallel. So you solve for y, and then you find the slope, right? And then if two lines are parallel, what happens to their slope? Let's say two lines are perpendicular, then their slope are opposite reciprocal, right, everybody? And what is point slope form? Y minus the y coordinate of that point equals to the m times x minus the x coordinate of that point, right? And so you plug in the slope and the point and express your answer in the slope intercept form. So that is y equals mx plus b, right? So you solve for y and then you can get the slope intercept form. And then here, remember composite function? This is f of g of x. So that means whenever you see x in the expression of f, you replace x by g of x, right? And you find the domain. What is special? Two things remember for the domain. When you see square roots, you need the things inside the square root to be not only positive, but greater or equal to 0. And then the second thing you check, fractions. We need the denominator not equal to 0. Right, everybody? Those are the for domain. And then here, okay. Remember two types. One type is the x variable is only in the absolute value. Okay? In that case, you isolate the absolute value, and then you use the fact that absolute value of x equals to a, that is x equals plus or minus a. So that is what happens when you have the variable only inside the absolute value. The second type is when you have the variable inside and outside of the absolute value. Then what you do, remember you put a line there, and then here you just ignore the absolute values. Okay? This one, you replace the absolute value of x minus 15 by negative parentheses, x minus 15. Right, everybody? And then you solve for x. So both cases, you will get a quadratic equation. Remember, you can solve quadratic equation by either factoring or quadratic formula. Okay? But when you solve that, there are three possibilities. You might have two real roots, or one real roots or zero real roots, okay, which means there are two complex conjugate roots. But in this case, we're looking for real solutions. So that's why you might have like two real root or one real root or zero real roots. If there's no real root, then you just say no real solution. And if you have a solution, you need to plug in and check. Remember, everybody? Mm-hmm. Yes. And I can tell you this problem is kind of easy. You get nice number, but the problem on your exam is not very nice number. It's hard to make up a problem with nice number. Yeah, so I can just tell you if you see something crazy, the number in the exam, that's normal. Okay. Yes. Questions? Yes, this is the practice exam on the website. Yeah, it's on it's on the course website, the bottom of the course website. Remember, you first use pencil to finish your work in 1.5 hours, and then once you click the solution, use red pen. Okay, use red pen. Not only grade it, okay, write out the correction, but also estimate your score. So each problem has some points. So you estimated your score on each problem and add them all up to get the total score. Is that clear, everybody? Yes.
Are we just getting graded for doing it, or the grade that we ended up getting on the test?
The score is the score on the practice exam. Okay. Yeah. Yes. So, like, for example, solution. Okay. So each problem has some points. If you get a mistake, then you subtract 1 point, and then you count how many points you get on this problem, and then finally you have your total scores. Because I want you to see, oh, if I lose so many points on this problem, then you can find some similar problem to practice. Okay, maybe make up some problem to practice. Okay, everybody? So yeah, so how do you review? You review your class notes. You review your homework. Plus your homework. Remember all your homework? You can click view details. You can see all the homework solutions, right? And also your quiz. Review your quiz. On the website we have the file with quiz mistakes, right? You can see all the mistakes. And then yes, do the practice exams and yes. Okay. And we also have like more exercise from the Mobius lessons, right? Mobius lesson also have some practice like the try me exercise. You can generate, you can like try another problem, then it will generate another problem to practice. Okay, and what else? Right. Okay. This one, yeah. This is this is equation involving rational expressions, right? Okay. So yeah, find some similar problem to practice. So this is absolute value inequalities. We first isolate the absolute value and then we break them. Right. Thank you. Oh, Pastor, you haven't signed it? Right. So remember, if absolute value is less than a, that means the distance is small, right? So small. How small? Bounded between -a and a. Okay? If the absolute value of x is greater than a, that means distance is big. Big means outside this range. So it's either x less than -a or x is greater than a. Right, everybody? Mm-hmm. Okay, and yeah, this is complex numbers, so practice that. And this quadratic equation, oh, for those of you coming late, don't forget to sign in. Yeah, you can use whatever method you want. So quadratic formula, remember that. And here, write it into the standard form and sketch its graph. The standard form also called the vertex form. So it's a times x minus h squared plus k. Right, everybody? And how do you find your h? Your vertex is h comma k. H is negative b over 2a. And then k is figure out the standard form, you can draw the vertex and the axis of symmetry. Axis of symmetry is a point, a number, a line, right? A line means an equation. You say x equals to the h, right? It's an equation. It's a vertical line. And then, yeah, depends on A. If it's positive, then the parabola opens up. If A is negative, the parabola opens down, right? Okay, and yeah, this problem similar. We can write on the standard form. This is a vertex, so this is the H, this is the K, and because the parabola passed through this point, we can plug in x is -1, y is 3 to solve for A. Okay, everybody? So for these type of problems, we have some in-class example, and so you can like review your notes and then you can try these problems. And then this one, yeah, we just talked about that last week, right? You first find the x-intercept, right? You set each factor equal to 0 and solve for x. Those are the zeros or roots of the function. And to find y-intercept, you plug in x's 0. Awesome. And x-intercept, they are points. So you have the x values, comma, 0. The y coordinate is 0. And y-intercept is 0, comma, the y value. And then, remember, you look at the leading coefficient to see whether it's positive or negative. And how do you find the leading coefficient? It's the 5 times the coefficient of x squared, coefficient of x squared, coefficient of x heats to 7, right? It's the coefficient of the highest power term in each factor, and then you multiply them. Okay, that's the leading coefficient. If leading coefficient is positive, you start with the top right. If coefficient is negative, bottom right. And you look at the multiplicity of each root. It is add, plus, it is even, balance. Right, very good. Awesome. So, and behavior. So I asked and behavior. That means after you draw a picture, you tell me when x goes to infinity, what happens to your y? If it goes this way, what do you say? Y goes to infinity. If it goes this way, what do you say? Negative infinity. And then you talk about when x goes to minus infinity. If it goes this way, y goes to infinity. This way, negative infinity. Very good. So that's why when you look at the solution, okay, the solution, you can see the points, okay, how the points are distributed. Okay, so you become the grader and grade it. And then this one we just learned last week, okay? And so similar, we don't need to draw the y-intercept, right? We only find the critical numbers, and then you decide whether to put open circle or solid circle. We also talk about the leading coefficient, but the leading coefficient is going to be the coefficient in each factor. You either multiply them or divide by them, okay? And we don't need to know what is that number exactly. We just care about whether that number is positive or negative. Right, everybody? Okay. So this is inequality. So at the end, you need to write down the interval notation. Okay? So that is our exam. If you have questions, feel free to email me or come to my office hours. So these are my office hours. Monday, Wednesday, 3:15 to 4:45, and Friday, yeah, Friday is after our exam. Maybe you will ask me questions on Friday. Okay, and Tuesday, Thursday, 11 to 12, and 2 to 3 p.m. Or if you're not available during my office hours, feel free to email me. I don't mind to have virtual meeting with you in the evenings. Okay, but on the Thursday night, I usually sleep at 11. So if you email me at 12, I cannot email you back. Okay? Yes. All right. Hey, do you know we have a tutor.com? So let's see. Okay. go to this website. So, and then you can click tools. And let's see, there's a tutor.com online tutoring. Have you tried this before? This is 24 hours, 7 days. So you can click the subjects like math, okay? And you can click math 1030, which is not here. Interesting. Okay, but it's okay. You can click the college algebra. So our precalculus is like combination of college algebra and trigonometry. So right now our chapter is like college algebra. So you can click that, and usually you submit a questions, and then someone will respond to you within 3 minutes. I believe that. Yes. So if I'm sleeping, you have questions, you can go to tutor.com and ask your questions. Okay, everybody? Mm-hmm. Awesome. Okay, let me see. Do you have any questions here? Let me check the questions file. Okay, no? All right. Yes, so if you have any questions, feel free to let me know. And then today, we talk about session 3.5. Yeah, our plan is today you do the quiz, and then on Wednesday, we'll talk about the quiz solution and go over the quiz mistakes. Okay? Yes, then you'll be ready for the exam. Awesome. So let's see, 3.5. Dividing polynomials. So last we call how do we divide numbers? Okay. So we use 39 and then divide it by 4, right? We put the 39 inside and the 4 outside. And then we think about, okay, what multiplied by 4 is smaller than 39? Okay, we can do like 6. 6 times 4 is 24, but it's too small. 7 times 4, 28. We can do more. 8 times 24, 32. And 9. 9 times 4 is 36. So we put 9. Right, everybody? And that's 36. And we use the first line to subtract the second line. Yes, everybody? So that's why 39 minus 36 is 3. Okay? Something wrong with my pen. Okay. And we call this is the 9 is the quotient. And 4 is the divisor. And the 3 we call it the remainder. Okay? So now we can rewrite 39 over 4 to be the quotient, which is 9. It's something wrong with my pen. Let's see. Okay. All right. Okay. So 9 plus the remainder 3 over the divisor 4. Is that okay, everybody? So this is how we rewrite the number. So that's quotient plus remainder over the divisor. Okay, everybody? So now, how do we divide polynomials? It actually works similarly. So we have p of x divided by d of x. And then we can do the division process. We'll get the quotient and remainder. So we can write so p of x is like the dividend, d of x is the divisor, and then we can express that equals to the quotient plus the remainder over the divisor. Okay, so for polynomial, it works similar. Okay, and in other words, well, how do you get this? Well, you both sides multiply by d of x, right? You both sides multiply by the divisor, and then on your left hand side you get p of x. On your right hand side, you distribute. That's why Q of x times D of x, and then the next term D of x and D of x cancel, you get R of x. So these are the same. Is that okay, everybody? All right, so now how do we divide polynomials? Okay, so we draw the long line. We put 3x, we put the dividend inside. So 3x to the 4 minus 5x cubed. Okay, when you write it down, you want to put them in order. So from the highest power to the lowest power. Do you see the highest power is x to the 4th? And then next term, x cubed. And then the next term will be questions. Okay. This one we cannot do synthetic division because this is the divisor is x squared. The synthetic division only works when we have linear factor. So we will do both. We will first talk about long division and then we'll talk about synthetic division. So we will talk about both today. Yeah. Okay, good point. So you see the next term is the negative 20x. That means we are missing x squared. Right, everybody? So you can put like 0 times x squared here because we don't have x squared. Yes, everybody? And then minus 20x minus 5. So we put the dividend inside this symbol. And then divisor outside. So x squared plus x plus 3. Is that okay, everybody? So make sure we order it so it's highest term to the lowest term. Okay, now what do we do? Okay, so you look at the highest power term and then you think about, okay, what multiply by x squared to get 3 times x to the 4th? Yes! Right, everybody? 3x squared multiplied by x squared, we got 3 times x to the 4th. So we put 3x squared right here. Okay? And then okay. So like how we did here. So we put the 9 and then 4 times 9, we put it right here. So now 3x squared times x squared. We get 3x to the 4, right? And then next, 3x squared times x. 3x third. And 3x squared times 3. 9x squared. Yes, everybody? So we use that term, 3x squared, and we multiply by the divisor. We get this polynomial, right? And now we use the first line, subtract the second line. Is this how you do it when you work with number? Because I know maybe some of you teacher might teach a little bit different way. So my teacher say I use the first line, subtract the second line. And maybe some student, your teacher teach you, oh, put a minus sign here, and then you add those two lines. So how did you learn it? You do subtraction, or you put a minus sign here and say you add those two lines? Subtraction, right? Okay. So, okay. Yeah, because the previous semester, some of my students, they said, oh, they learned differently in high school. So the teachers, they put a minus sign in front of the line, add them. Yeah, so just be careful. Okay, we use the first line, subtract the second line. Do you see 3x to the 4th, they cancel? And then next term, negative 5x cubed minus 3x cubed is negative 2? Negative a, yeah, very good. Negative ax cubed. So that's why it's very, very important. Right, it's the first line, subtract the second line. How about next term? 0 minus 9? Yeah, negative 9x squared. And then we still have negative 20x and negative 5. Is that okay, everybody? Mm-hmm. Good. Now continue. Okay, so here, what multiplied by x squared to get negative ax? So what multiplied by x squared to get negative ax cubed? Negative ax. Is that okay, everybody? Awesome! Distribute. So negative 8x times x squared is negative ax cubed. Negative ax times x, negative ax squared. Negative ax times 3, negative 24x. Right, everybody? Mm-hmm. Awesome! Use the first line, subtract the second line. Do you see the first term cancel? Yeah, because minus become plus, right? They cancel. Okay, what's the next term? Negative. Yeah, very good. It's minus 9 minus negative become plus 8. So minus 1x squared. Okay, next one. 4x, right? Negative 20 minus negative 24, it becomes negative 20 plus 24, right? And next, minus 5. Good. Okay, so last one. Okay, last one. What multiplied by x squared to get negative x squared? Negative 1. Yes, everybody? Mm-hmm. So, oh, we distribute. So that's negative x squared and then negative x. Negative 3. Yes. Okay. Do you see the first term cancel? And then second term. How many x? Yeah, very good. And then negative 2. Awesome. Oh, do you see the remainder, the degree is 1. The divisor, the degree is 2. So your remainder is smaller. The degree is smaller than the divisor. Then we are good. Okay? Yes, that's always the case. Remainder has the degree is smaller than the divisor. So now we can write down, okay, this quotient, so this fraction equals to the quotient. What's the quotient? 3x squared minus ax minus 1, and then add the remainder. 5x minus 2 over the divisor. So this is the answer. Is that okay, everybody? Mm-hmm. All right, let me also write down the steps so you can, like, when you review the notes, you know what we are doing. Okay, so the first steps, we reorder it from the highest to the lowest terms. Okay, so we order the dividend and the divisor. A second step, we want to match. So we want to multiply. Okay, so we match. Okay, what times x squared to get 3x to the fourth? Then you realize, oh, that's 3x to the square, and then you multiply the divisor, right? And then we use the first line, subtract the second line. Okay, and then we repeat the process until you get a smaller degree remainder. Is that okay, everybody? I think it's good to like summarize the steps. So then when you work on a new problem, you can look at the steps and see, and then kind of recall your memory. So far, so good, everybody? Okay, now it's your turn to work on this problem. Who hasn't signed in? You're doing it manually? What? And then what this is pretty good. So you should have 3 on the left. And then x, you have x squared here, and you need x before, so you need to multiply x squared. That's why the question mark is 2x equals 0. Yeah, I think for that you can this minus 8x. So what multiply by x squared you get minus 8x, which is minus 8x squared. Oh, minus 8x. Yes, yes, there's 6. This first line, yes. Yes, this minus that one. Okay, let's check our answers together. So we have the 18x to the 4 plus 9x squared and plus 3x plus. I found this on the web for x to the 4 plus 9 times Claire. Check it out. Thank you. I'm not asking you. Interesting. Yes, I Siri somewhere. Okay. So 3x squared plus 1. Okay. And yeah, what multiply by 3x squared to get 18x to the 4th? Yeah, 6x squared. And then when we distribute, that's 18x to the 4th
and 6x squared, right? And use the first line, subtract the second line, we get. Oh, yeah, yes. But in this case, because the x is also missing, so yeah, if you get used to it, then you don't have to put like the zeros. But make sure you put them in the correct spots. Okay. So, okay, to be consistent. Okay, maybe let's just move this further away. Okay. Let me see. E. Okay. Yeah, so we can do 0 x cubed. And then do you realize here we also missing x cubed? So just don't put anything here. And then you have the 6x squared here. Is that okay, everybody? So when you do the subtraction, this is gone. And 9x squared minus 6x squared, you get 3x squared. And plus 3x plus 2, right? And 1 multiply 3x squared, you get 3x squared. 1. Okay. So that's why we distribute 3x squared and then plus 1. Right? So we put the 1 here under the constant. So don't put the 1 here. Okay, everybody? Make sure all the like terms are aligned. Okay, use the first line, subtract the second line. And what do we get? Yeah, 3x plus 1. And this is the remainder. So our fraction equals and then plus, yes, good, very good. Okay, so this is long division, and long division works in general. Okay, it works for the degree greater equal to 1. It works for all the divisors. And then the way we think of it is very similar to the way that we divide numbers. Okay. Okay, the next one that we're going to learn is called synthetic division. So synthetic division is a quick way to divide it by something of the form x minus c. Okay, it only works for the form x minus c. So if you have like x squared minus c, can you do synthetic division? No, okay? It only works for the form x minus c. If you have something like 5x minus 9, can you do synthetic division? Yeah, but you need to modify something. So my suggestion is don't do it. Okay, you only do it when you have the divisor is x minus something. So your coefficient of x is 1. Is that clear, everybody? Yeah, because if the coefficient is like not 1, let's say 5x minus 9, then the synthetic division not work exactly the same. We have to modify it. Okay, so my suggestion is we only use synthetic division when your divisor is x minus c. So the coefficient of x is 1. Okay, everybody? All right. And other types use long division. Okay, what is synthetic division? It's a quick way. So how we do it? So first of all, we want to divide. So the divisor is x minus 2. So it corresponds to the root is 2. Is that okay, everybody? The roots, the corresponding roots is 2. When you see the factor x minus 2. Okay. Do you remember last week when we have like 5 x minus 1 squared 2x plus 3 equals to 0? And then we say, oh, this factor x minus 1 equals 0. But the root is 1. Yes, everybody? And we say, oh, this factor 2x plus 3 equals to 0. But the root is negative 3 half. Yes, everybody? So if you see the factor x minus 2, the root is 2. Okay? All right. So what we do is first, we draw a vertical line, and then we draw a horizontal line. Okay? And you put the 2 right here. Okay? So you don't, unlike the long division, you put x minus 2 there, but here, the simplified division, you only put the root, not the divisor. Is that clear, everybody? Okay, and then here, don't put the x, only put the coefficient of x. Okay, so the coefficients. So here we put the coefficients of x. So coefficients. And we have 1x to the 4th, and then minus 1x cubed, 1x squared, minus 1x, and 2. Is that okay, everybody? We just put the coefficients. And make sure the order is from the highest power to the lowest power possible. Okay? Alright. Now, what do? Okay. So, first steps. We move down this number. So, first step, we move down this number. Okay? Let me also put down the step here. So, the first step, we move down that number. The first step. Okay? And second step, we multiply the 2 and the 1, and we put that number here. Okay? So multiply with the roots, okay? And write down in the next column. Okay? We use 2, so this number, move it down. And then multiply with the roots. Multiply by the roots. So 1 times 2 is 2, and then we put it in the next column. Is that okay, everybody? So 1 times 2 is 2, and then we put down in the next column. So this is the second step, right? So multiply by the roots, multiply by the roots. Okay. And then write it down in the next column. Okay, the third step, add the second columns. So add the numbers in the second column. So minus 1 plus 2, what's that? 1. Yes, everybody? And then we repeat the process. So we get 1, and then we multiply by the roots, which is 2, and put it in the next column. 1 times 2 is 2. Okay, add the numbers in this column. 1 plus 2, 3. And 3 times 2 is 6. Yes. And then add the numbers in this column. 5. 5 times 2, 10. And then 12. Are you okay with this process? So step 1, move that number down. And then step 2, multiply with the roots, and move it, write it down in the next column. And then add the second columns. Okay? And then this number multiply by the roots, and then write it down in the next column, add them up, and this is what we get. Okay, what does this mean? This means, okay, look at the last number. This number is the remainder. Okay? And then these are the coefficients of the quotient. Okay? So that means your constant term is 5, and then this is 3x. This is x squared. This is x cubed. Is that okay, everybody? So you look at the last number, that's the constant. So 5. And then next number, 3x. Next number, x squared. And next number, x cubed. Yes. So this guy equals the quotient x cubed plus x squared plus 3x plus 5 plus remainder 12 over divisor x minus 2. So far so good, everybody? Yes. How we get this? Okay, these numbers are the coefficients of the quotient. So that's why you start with 5. 5 is a constant. And then next one you increase the power to 3x. Next one you increase power to 0. This one you increase power to 0. Yes. Any questions about this problem? Okay, now you do the next problem. Practice. What is your root? Is your root 2? There is no x. So there's 0. Do you see there is no x? There is a column 0x. Okay, let's continue. Awesome. So we have, okay, so we have what's the roots? Yes. And then the coefficient 3, -2, but the next one is 0 because there's no x. And then 35. Okay? So this is very important. This is yeah, that's very important. Don't miss the x. And then, okay, first step, oops. My pen is not so good. First step, we move the 3 down. And then 3 times -2 is -6. We add them. We get -8 Negative 8 times negative 2, 16. Add them. 16. 16 times negative 2, negative 32. Add them. 3. Right, everybody? So 3 is the remainder. And our quotient is, we start with the constant term and then negative ax and then 3x squared. Very good. So this is 3x squared minus 8x plus 16. And that remainder 3 over x plus 2. Is that okay, everybody? Yes. That is synthetic division. Okay, very good. And let's continue. Zeros of polynomial function. Okay, we have the remainder theorem. If the polynomial is divided by x minus c, then the remainder is the value p of c. Okay, and why is that? Okay, why is that? Okay, so we have p of x. Okay, so p of x, we want divided by x minus c. And then we know that's the quotient plus the remainder over the divisor. Is that okay, everybody? Yeah, that's the quotient plus the remainder over the divisor. But because the remainder always has the degree that is less than the degree of the divisor. In this case, the divisor is degree 1, right? Which means the remainder must be a constant term. Do you agree, everybody? So that's why the remainder is actually a constant. Okay, it's a number, a constant. And therefore, this is the same as saying P of x equals Q of x times x minus c plus the remainder. Do you agree, everybody? We just multiply both sides by x minus c. Now, if we plug in c, we get P of c, right? We plug in x equal to c. Well, do you see what happened to this guy? C minus c is 0. Oh, we get P of c equals to 0 plus the remainder. Yes, so that is why the remainder is actually the value P of c. Is that okay, everybody? Okay, so instead of finding P of c by directly plugging in x equal to c, we can instead to use the synthetic division, since the remainder will be P of c, to find the remainder. Okay, so let's look at this example. Wow, P of x, this is so big, right? This is a polynomial degree 5. And we want to find P of negative 2. Well, usually you want to find P of negative 2, you plug in x is negative 2, and then you might need to use your calculator in this case, because it's a big number, right? But we can use the remainder theorem to find the remainder. Okay, so let's see, how do we use the remainder? Okay, so we find the remainder. So find the remainder of P of x divided by x minus c. In this case, c is what? The root is negative 2, right? Negative 2. So what's x minus c? X plus 2. Do you agree, everybody? Yes. So the root is negative 2. Okay. And now we put the root negative 2 here. And this polynomial, what are the coefficients?
3, 5, -4, and then 0. Very good, because no x squared. And then 7 and 3. Okay. First step, move it down. 3 times -2. -6. Add them. -1 multiplied by -2. 2. Add them. -2 multiplied by -2. 4. Add them. 4 times -2. Add them. -1 multiplied by -2. Add them. Oh, do you see the remainder is 5? Then by our remainder theorem, P of -2 equals 5. See, we don't need a calculator. So far so good, everybody? And yes, sympathetic division. Here we're using sympathetic division. And we only use it when we have the form x minus c. Okay? Any questions? Okay, so today you have the quiz and try to finish your homework. Okay? And then you can print the solution, save as a PDF. You can review it and prepare for it. Practice exam is on our website, so we're going to practice exam